Alright, here we are, 3.2 growing dots. So you should have this paper in front of you. Now, remember, we're still dealing with sequences, so we're looking at patterns. Okay, so I'm going to give you guys some time to try to work through this on your own. And you should be working together with those people you're seated next to, discussing, seeing what they got, going with what they have. So we're taking that pattern, and here's the whole pattern as you see it. Okay, so at the beginning, at 1 minute, at 2 minutes, at 3 minutes, and at 4 minutes. Okay, so you've got to figure out how is this pattern growing. So if we look at number 1, it says describe and label the pattern of change you see in the above sequence of figures. So how are we going to be able to describe it? What can we use? And label the pattern. Okay, so remember, we've got those models we can use to help us understand. So the models are a table, okay, a graph, that picture, or we could do what it's kind of asking us to do in 3 and 4 is a formula, an equation. Okay, those are the other one we can deal with, and that we have the recursive version and the explicit, which it wants us to do both. So first thing you need to do is describe and label the pattern of change you see in the above sequence of figures. Okay, try to figure out what's happening here. Then, assuming the sequence continues in the same way, how many dots are there in 5 minutes? Okay, so those are the first 2 questions I want answered. So let's give ourselves about 5 to 10 minutes. Have your guest teacher give you more time if you need more time. So pause the video and try to work through and see if you can figure out 1 and 2. Then we'll talk about 1 and 2, give you some time to work on 3 and 4. If you do finish 1 and 2 in time and you want to try 3 and 4, go for it. Okay, so it should be paused right now. Okay, so it should have been paused, and you should have had time to work on it, so we should all hopefully have been able to figure out what's going on here for number 1 and 2. Okay, so how many dots are there at 5 minutes? So I'm going to make a table here. So minutes, dots. So we have 0, 1, 2, 3, 4, 5. And 5 minutes, that's what we're looking for, right? So how many did we have at 0? At the beginning we had 3 dots. At 1 we had 6 dots. At 2 minutes we had 12. At 3 we had 24, and at 4 we had 48. Okay, so if we were looking at this pattern, I want to deal with the pattern first to kind of talk about that. So as we're looking at this, we should see, okay, we've got basically 3 groups each time, right? So if you kind of wanted to, you could just think about it 1 group at a time, right? Sometimes that's easier to figure out. If we can figure out what's happening to 1, they're all kind of doing the same thing, right? So would it be easier to deal with them just that way? We go from 1 to 2 to 4 to 8 to 16. So if we were adding, we could add 1, but if I added 1 again, that would get us to 3, not 4, right? So I could add 2, and add 4, and then add 8, but with an arithmetic sequence, you have to be adding the same number every time. So that's not going to work, so what else can we do? Well, how else can we get from 1 to 2? Well, we could times by 2. Would that get us to 4, timesing by 2? Would that get us down to 8? Or to 16? Yeah, in other words, you can kind of look at it this way. Got 1 here, so if I double it, that gave me 2. Took that and doubled it, that gave me 4. Took 4 and doubled it, that gave us 8. Took that 8 and doubled it, that gave us each one of those, and then we're just timesing them by 3 because there's 3 sets of them. Okay, so does that work here? 3 times 2, does that give us 6? Times 2 is 12, times 2. Okay, so our pattern is multiplication. Okay, that is not arithmetic. Okay. Okay, when we have this pattern, we have another word to describe it. It's not arithmetic, it's geometric, because we're multiplying. So at 5 minutes, we should have ended up with 48 times 2, which would have given us 96. So, describe and label the pattern. We did, 3, 6, 12. What are we doing? We're doubling. We're multiplying. Remember, doubling is multiplying by 2. So if you said doubling, you were correct. Okay? So now, given this information, I want you to try to create that recursive formula and that explicit formula. And what we did last time can help you. So pull that out to see if you can figure out how to get that recursive formula and that explicit formula. Let's give ourselves just 5 minutes here. So take it and pause it, and we'll take a look at this. It should be paused, unless you already paused it. In that case, alright. So I'm going to leave the table up because that's very useful. So you should have had 5 minutes to work on this. If not, hurry and pause it now. So recursive formula. Remember, with recursive, we're always starting this way. F of x, let's call this x and f of x. F of x, the next term, say we wanted to find what 6 was, is equal to f of x minus 1, which stands for the previous term. Okay, and then what we're doing to it, the pattern. And what is the pattern here? We are timesing by 2. So the first part of my recursive is f of x equals f of x minus 1 times 2. Then we have to do the starting point. So we pick the 0. So at f of 0, the input of 0, my output is 3. So this right here encompasses every piece you need for the recursive. If you only had this piece right here, that is not complete. Even if you got all of these exactly right, that's still not complete. Okay, to this piece. So remember, f of x minus 1 times 2 equals f of x. F of x standing for all these results. Okay, we want this result, this next term. To do that, our input was 6. So we said at 6 minutes, how many dots did we have? Well, to know that, we need to go back to the previous term. Well, 6 minus 1 is 5. So at the 5th term, at 5 minutes, we knew we had 96. So we take that 96, we double it, we times it by 2. That'll give us our next term. Then we just also needed to know that this is where we started, because you got to start somewhere. So that's our recursive. That's what it looks like. Okay. Now let's talk about the explicit formula. This one's probably a little trickier, but if you would have used this idea that we talked about in the other one, that with the explicit it is f of x equals the start and the pattern. The starting number and the pattern. Okay, so if I went f of x equals, well, where did we start? We started at 3, right? That's our y-intercept. That's where we start. What did we do to 3? Well, we timesed it by 2. How many times did we multiply by 2? Well, we're just going to keep going, right? If I went to 4, we timesed 1, 2, 3, 4 times. Oops, I can't miscounted them, didn't I? It's still 4. 1, 2, 3, 4. If we went to 5, we went 1, 2, 3, 4, 5. Well, what is 2 times 2 times 2 times 2? Is there an easier way to write that? Yeah. Well, think about it this way. If we stopped it at the 2, what's 2 times 2? It's 4, but it's also 2 squared. What about if we stopped at the 3? 2 times 2 times 2, which is 2 cubed. So at 4, it would be 2 to the 4th. At 5, 2 to the 5th. So if we went clear down here to x, it would be 2 to the x. Okay? Because we're multiplying, now with the arithmetic version, the y equals mx plus b, that m times x was repeated addition, right? 2 plus 2 plus 2 plus 2. The shortcut of repeated addition is multiplication. So the shortcut of repeated multiplication is exponents. So do not put the x down here. That is incorrect. That does not work. The x, the variable, has to go up there as an exponent. And there's our explicit equation with, to get that next term, we take, that's not the previous term, that's the starting point, also known as the y-intercept, and then we apply the pattern. And the pattern was multiplying by 2. So, and think about this like this. Repeated multiplication is really exponents. Okay, that's what we're thinking here. So if you needed a format to write this equation, kind of like how we have the slope-intercept form, the way they write it is like this. Y equals a times b to the x, where a is your y-intercept, b is what you're multiplying by. Okay, so there's our equations, our recursive, our explicit, our pattern. Okay, so we're adding another pattern here, a new pattern. Okay, before we've just dealt with adding and subtracting, right? And those we graphed as linear equations. They were lines, straight lines, easy to deal with, right? Okay, so now that's one type of pattern. That's those arithmetic guys. Okay, but now we're adding another one called geometric. Okay, and geometric is multiplying or dividing. And really we typically only think about it as multiplying. Whenever we divide, we actually multiply by the reciprocal. So, what is that going to look like? That's what we are going to find out and deal more with. So, I know this was kind of a short one, so hopefully you guys got an idea. Remember, we're just kind of starting to introduce these geometrics, so we'll deal with more of these, okay? So if you're still a little lost, that's alright, we'll keep dealing with this. Just work through the homework, do your best you can on that. You probably will have plenty of time in class here to get this done, so make sure you're spending that time in class actually getting this homework done so that you'll be ready for the next class period. Alrighty? So we will call that good for now. Get that homework out, get working on it, and get some stuff done.